Hello and welcome back to another how-to video where we're going to be looking at the much anticipated direct die block for AM5. We're going to have a look inside the block, make a teardown of all the parts, and then we'll reassemble it and show how to delete the CPU and mount everything so you're ready to put it into your loop. We're going to start by taking a look at the contents of the box and then doing a teardown of the block. So this is the Signature Edition, and this includes Thermal Grizzly's D-Lit die mate and Thermal Grizzly conformal coating to protect the components on the PCB. Everything else you would get in the standard AMD Ryzen Edition that's not the Signature version, with exception of the big branded box and these two pieces. So on the top layer we have the block itself, which is exactly the same in both versions of the product, whether it's the Signature Edition or not, and the two extra pieces which come along with all the packaging. And in the bottom layers we find all the accessories, which is a die guard for the delidded CPU, Thermal Grizzly Conductonaut Extreme liquid metal, and all of the screws, tools, and a spare mounting stud for the block. So now let's take a look at the block, take everything apart, and we'll see all of the differences between the regular Velocity² and the direct die version which was made for LGA 1700, because this is a completely unique block internally that was made specifically for the AM5 layout of dies. So it's quite unique, and it also has a quite unique construction. On the outside it has an acetal terminal, which the threads for the G1 1/4" ports are inside, and it also has an aluminium cover which covers up the LED and conceals the majority of the screws around the side of the block. So the first piece we'll have to remove is the cold plate. You'll notice that this has contact patches specifically on the areas of the die, so it's finished as perfectly as it can be, and you know exactly where to spread out the liquid metal. You don't spread the liquid metal over the areas that the capacitors are directly beneath, so it gives everything a nice limit, and you know exactly how to apply it. The cold plate is attached by 4 asymmetric stainless steel screws, so it can only fit one way. And the cold plate and the entire block is also indexed to the die guard, so there's only one way for you to assemble everything. The block, obviously with its rectangular mounting, must always be vertical. Inside of the cold plate, the block is similarly specialized. You'll note that the fins are offset both horizontally and vertically, so they pass over the areas where the dies actually are located on a chip. And the stainless steel jet plate is keyed inside the cold plate and fits in only one orientation. It has a large chamfer on the inlet to accelerate flow into the fins, and a very short path out towards the bottom, and a longer path to the top over the I/O die. And the location of the jet and the orifice which the coolant comes through aligns perfectly with where the dies are. So all of the coolant that passes through the block passes over the dies and splits in half, as you would expect on a modern design. The block itself, you can see the two outlet orifices and the inlet. They're coming through the stainless steel midplate from the top and into the jet plate and through the cold plate. One other thing to note that makes the direct die cold plate very different to a standard Velocity² cold plate and most other CPU block cold plates is the thickness of the copper underneath the fins. So the depth of the fin is not as much, and there's about 1 millimeter of copper over the entire die, and that is to help spread the heat, because without an IHS there's nothing to spread the heat across the dies, so the base is considerably thicker than usual. It also helps keep it rigid and prevents it from bending the dies. Next we will take off the next part of the block. 3 of these screws on the right go into the terminal piece, and the other 3 go into the aluminium cover over the top. Again, these are stainless steel M4 screws, and the outer 6 are considerably longer than the inner 4 used for the cold plate, but they're all the same length, so you don't get the outer ones mixed up. So the next piece to remove is the mid plate of the block, and uniquely you will notice it has 4 standoffs threaded into it. Now, unlike the original LGA 1700 direct die block, this block utilizes these standoffs to prevent over-tightening. So the cold plate and the die guard do not actually hit each other, but these standoffs hit the motherboard and prevent the whole mechanism from being over-tightened. And because they're further away from the center of the block, they also help to keep it more stable, so you can't put it at such a large angle. Interestingly, they're also removable from the cold plate, and this hole is big enough for the entire spring and stud to pass through, which means you can replace the studs without disassembling the block. You just remove these standoffs with the hexagons. And that brings us on to the mounting studs and springs, which are encased inside of the block. These have a Torx T7 head inside the thread, a place with the thread removed, and that helps locate the block into the backplate of the motherboard before you start tightening it. And then you insert the socket from behind and rotate them backwards to tighten the block down. That tensions the spring until the shank of the mounting stud contacts the AM5 backplate. The next piece in the assembly is the plexiglass top, which has Ryzen engravings and chiplet details in the same style as the chip itself. You'll notice that this has 2 additional O-rings on the top side. They contact the terminal, so there are no 1/4" threads in the plexi, but rather in the terminal. The terminal seen here, that's a small piece of machined acetal that's clamped by the threads through everything. And the last component is the aluminium top cover. You can see it's solid machined aluminium with space for a dense LED strip inside, and that illuminates the top portion of the plexi and all the coolant and engravings. So now that you've seen absolutely every part of the block, let's have a look at delidding the Ryzen R9 7950X CPU. This applies to all 7000 series CPUs that are packaged with this style heat spreader, and we're going to be using the delid tool that's included in the Signature Edition kit. This is the Thermal Grizzly Direct Die Mate. You can also purchase this separately if you had the non-Signature Edition, or if you already had this, then there's not much reason to buy the Signature Edition. So the first thing that we're going to do is remove the screws from the top and insert the CPU. So as you can see on the inside of the delid tool, the CPU is indexed by a triangle. So we'll place the CPU inside with the lands down corresponding to that triangle. The top can be inserted in either direction. That's symmetrical, as is the heat spreader. So we'll place that inside and make sure it's located properly around the IHS, and reinstall all of the screws from the top. The next step is to reinstall the screws from the side. One of them needs to be tight. Meanwhile, the other one must remain loose so that it doesn't hold back the sliding mechanism. So one can just be loose inside. And you can see at the moment, the slider is perfectly centered on the CPU. It's at neither extreme. Now, to deal with this CPU, you can apply heat in the same way as we recommended for Intel LGA 1700. But since the surface area of the solder and the surface area of the glue that holds the IHS to the PCB is much smaller, it's not as necessary, but it is a sensible precaution to use either a heat gun to warm up the entire assembly or put it in an oven to warm it up very gently and ensure that it's warmed consistently and all the way through. If you do choose to do that, as with Intel, we would recommend about 70 degrees centigrade for half an hour to ensure everything's warmed up. But by the end of the process, it will have cooled down again because you have to move this so many times to get it to yield. So the process will go that one side is tightened, then the screw is loosened, the opposite side is tightened and then loosened and repeated until eventually the IHS yields and falls away. We should see that the slider becomes loose inside the mechanism in the end, and then we'll be able to take it out and pop off the lid. So let's begin with the first, which will surely be the toughest. I'll make sure that the opposite side's loose. So unlike if you attempt to do this with LGA 1700, when the CPU is cold, there's no cracking, it's very smooth, and it moves with very little resistance. So again, now before reversing it, remember to loosen this one and repeat from the other side. Once you can see the slider gets to the end of its travel, don't continue to force the screw because that's just going to abuse the threads. Make sure it's loose and go back to the opposite side and repeat. So there we go. After about 30 repetitions in either direction, the IHS came away very easily. I just flicked it off, and now we're ready to start cleaning up the chip. There are certainly some traces of solder, but the majority has remained on the IHS, which is quite fortunate. And we'll also need to clean up all of the glue so that it doesn't interact with the die guard, and then we can protect all of the little capacitors and resistors that surround the dies. So the first thing that I will do to clean this up is use probably just a blunt plastic tool to break off any large pieces and clean it mechanically before going forwards with liquid metal to form an alloy with the remaining solder, ball it up, and then clean it off once again with alcohol so it's all ready and nicely prepared for the final application of liquid metal. Now that everything's cleaned mechanically and all of the glue has been taken away, and I've made the first application of liquid metal, I'm going to leave that for a little while before I clean it off, just to try and get the dies as clean as possible. So in the meantime, I will apply the Thermal Grizzly shield to the surrounding components. Now, it's important that it's applied quite thickly so that it's not immediately cleaned off by any alcohol you might use to remove liquid metal, but at the same time, don't go over the areas where the glue previously was. You should, I mean, even when it's well cleaned, you can still see where the glue used to be and the marks on the PCB from that. So try and avoid going into those areas because that will affect how the die guard fits on. But otherwise, actually where the individual components are, make sure that there's a nice layer of this. Now that the conformal coating has dried, I'm going to be using the Q-tip again to roll up all of the liquid metal, collect it in little balls, and hopefully with that it will remove all of the solder and leave the dies nicely prepared for the final application. I will use the alcohol wipe to wet the Q-tip rather than trying to apply it directly with the alcohol wipe, because I'd probably start cleaning off the conformal coating. But if you had it completely bare, that might be a good way. So now with the Q-tip soaked in alcohol, I'm gently pushing all the remaining liquid metal into the middle, collecting it all up, and then we'll wipe that away with the alcohol wipe. But it looks to be a very clean application. Possibly the side we used earlier that doesn't have alcohol might pick it up. I'll attempt it. It still wants to repel it, so I'll have to pick it off with this. Yeah, it doesn't want to scoop, it just want to ruin the mat. Ah! So the CPU is now ready to be mounted in the motherboard. It took 2 iterations of cleaning, both mechanically and then with alcohol, to clean up the dies. They don't look as shiny as they could, but they're completely free from solder. They're very flat and they're very smooth. They could be polished if you wanted to go an extra step right now, but this is adequate to get good contact with our blocks. So now the motherboard. To install the die guard, you have to remove the loading mechanism for the CPU. And to avoid the backplate falling off during the process, it makes sense to put something under your motherboard. So I have just a little piece of foam that fits inside the backplate hole, because motherboards with the backplates let this fall away and then the screws aren't long enough to pick it back up and you have to turn all the socket over. So I'll place this behind and put it down flat, and this way the backplate won't fall off. The first thing to do is unhook the latch, and then we will use a Torx bit to remove the original socket. So with the loading mechanism away, we can install the CPU. The diamond marking goes to the top left corner where the little square protrusion is on the socket. It may be marked on the motherboard as well. So that fits up there, and then our die guard also has a cutaway for that little square, so it can only fit in the correct way. To reinstall the die guard, use the supplied button head UNC screws and just put them in very loosely at first so you don't pull the die guard out of flat. Put all 4 in loosely and then very slightly tighten them. These are not applying pressure for the block, you know, tightening these will not improve the thermal contact. It's just there to protect the PCB and to make electronic contact with all the pins. So it does not need to be very tight. If you have the 0.6 Newton meter Torx screwdriver, that's perfect. Now we are ready to apply the liquid metal. We'll be applying a small amount to each of the 4 contact surfaces. Obviously the I/O die, the CCDs, and the corresponding contact patches on the block, and spreading it out with one of the supplied Q-tips. And then finally we'll bring the block and the motherboard together, and that will be it, ready to install into the loop. So we need just a small amount on each surface. So now the liquid metal is spread on all 4 of the surfaces, it's time to put the block on the motherboard. We'll have to locate the 4 mounting studs in the holes, and since the first few millimeters don't have any thread, they should hold in position quite easily. I'll place the block down onto the motherboard. Now, as it sits now with the ends of the studs in the hole, the cold plate won't touch the die yet. but the die is held in by the die guard, so everything is fine. We will flip it over and then begin to screw in with the 4 outer screw holes the mounting studs. And to do that, you must rotate the Torx key in reverse, so counterclockwise. And it's best to do just a small amount at once, a maximum of 2 turns in each corner. Now, when you start to see the screws protruding from the back of the motherboard, that means they're nearly tight. They have just about a turn left, so be quite gentle. You will not get a better mount if you over tighten them, because once they stop, there is no more tension put on the spring, and that's to limit the torque and limit the force applied to the CPU. So once they have stopped, the block will be ready to use. And there we have it, a direct die block for AM5. It's fully compatible with Matrix 7, so you can integrate it with any distribution plate. The port placement is very similar to a standard Velocity². They are 28mm apart. The lower port is the inlet and the upper port is the outlet. Due to the layout of the CPU and the distinct asymmetrical placement of the dies, this is the only orientation you can mount the block. And as I said, it's much better to use the lower port as the inlet, so coolant passes directly to the chiplets and then splits and returns to the outlet. So I hope you enjoyed this video. Good luck with your new water block, and if you want to check out how it performs, we're also making a roundup of all of our AM5 cooling solutions. So you can see the Nucleus 240 AAO, the 360 version, a Velocity² for AM5, this block, and finally the Nucleus AAO direct die for AM5. We'll be getting a Cinebench core for them all and testing the thermals in a fixed workload. So stay tuned for that. Subscribe so you don't miss it, and leave us a comment down below. Thanks for joining us. I hope you enjoyed the block and much cooler temperatures.